So let's apply this process at the top of the page to these last two examples. Is there a GCF for this function? Yes, there is. The GCF that will divide evenly into all three of these terms is -4. If I divide out -4, that'll give me t squared plus 11t plus 18. Keeping my GCF in front, I'm going to set up my double parentheses. And I'm going to ask myself, what times what will multiply to make the first term? What times what makes t squared? That would be t times t. And then I'm going to ask myself, what are my factor pairs that make the last term? My last term is 18. What are the factor pairs that make 18? It could be 1 times 18. Always start with 1, kids, so that you don't forget about it. 2 times 9 or 3 times 6. What do you think that we should try? Let's try the middle one, 2 and 9. If I put a 2 here and a 9 here, is that going to work? And what about the signs? Since I have all positives going on, this part is easy. All positives going on. How do you know if this matches this? Well, I don't have an area model, so I can't look at the diagonal parts, but I can multiply this together to see if I'm correct. T times t is t squared. T times 9 is 9t. 2 times t is 2t. And 2 times 9 is 18. When I look at my like terms, that would have been in those spots here and here in the area model. 9t plus 2t is 11t. Is that the middle term that I wanted? Yes. So I know that this is the factorization of this that's correct. But it's asking me to find my x-intercepts and graph my function. How do I do that? I am going to use the zero product property. Take the factor, t plus 2 equal to 0. Take the other factor, t plus 9, set it equal to 0. I do not have to take this factor and set it equal to 0 because there's no t here. What plus 2 equals 0? -2. What plus 9 equals 0? -9. So my intercepts then would be at 1, 2, -2, 3, 4, 5, 6, 7, 8, 9, -9. And does this parabola open up or down? Looking at my leading coefficient, this coefficient is negative, therefore this parabola opens down with intercepts at -9, 0 and -2, 0. Just a preview of what would be coming up, we would be able to look halfway in between these x-intercepts and find the line of symmetry, but not today. Here, for this function, f of x, do I have a GCF for these three terms? I do not. So I can go instantly into what times what makes the first term. What times what makes 9x squared? Well, I have a couple of choices going on here. It could be 9x times x, or it could be 3x times 3x. We can try either one, it doesn't matter. And then, what times what equals the last term? Well, my last term is just 1. I have no choices. 1 times 1 equals 1. And let's think about the signs. This is positive, which means either this is positive and this is positive, or they're both negative. A negative times a negative makes a positive. But somehow I have to get a middle term to be negative, so I'm choosing to make both of these negatives so that that happens. What do you want to try? You want to try 3x and 3x? Okay, let's see what happens. How do I check and see if this is right? I'm going to double distribute. 3x times 3x is 9x squared. So far, so good. 3x times -1 is -3x. -1 times 3x is -3x. And right there, I know I'm incorrect. This would combine to make -6x. Not -10x. No problem, I have an eraser. Let's try 9x and 1x. 9x times x is 9x squared. So far, so good. 9x times negative 1 is negative 9x. Negative 1 times x is negative x. And a negative 1 times a negative 1 is a positive 1. These combine to make the negative 10x that I wanted, so I know that this is correct. And now I'm going to do the zero product property. 9x minus 1 equals 0. 9x equals 1. X equals 1 over 9. You can do all the work to find this intercept if you want to. I'm just doing it quickly for instructional purposes. And here, x equals 1. This parabola will have intercepts at 1/9 and 1. And it is going to open up because the leading coefficient is positive.